Hi, my name is Will Pincek, and I'll be doing a learning byte on Contrail Enterprise Multicloud uh, by performing what we call the Greenfield Underlay, onboarding a Greenfield IP fabric. So let's first talk about what that is. So what is the purpose of the Greenfield Underlay use case? This is where you have what's called an all-in-one server. An all-in-one server hosts a one-box implementation of OpenStack with Contrail networking. So it's got OpenStack, Contrail networking, and also DHCP running on a single all-in-one box. So we call it the all-in-one server. And that, along with the command server, which hosts the command user interface, that's used to discover and auto-configure a Greenfield IP fabric. So a Greenfield IP fabric is actually an IP fabric where you have the spine and leaf nodes appropriately cabled, but every device is in the factory default state. You know, one of the issues with an IP fabric is that the initial setup of an IP fabric can be quite grueling. You know, let's say you have 50 nodes in an IP fabric. Well, you'd have to go in and configure each one for interface addressing, loopback addressing, and routing protocol so that you can reach all the other devices in the IP fabric. So it's kind of a daunting task. What this is going to do is take these factory default devices that again are appropriately cabled, okay, and discover them automatically. The AIO server will eventually discover them automatically and auto-configure them for all those things I just mentioned, which are interface addressing, loopback addressing, the routing protocol, so that you can ping from loopback to loopback of every single node in the device in the IP fabric. So it's going to build the underlay routing protocol, but it's going to do it specifically using eBGP, so it'll be eBGP peering sessions is what it's going to build in that IP fabric, but it's going to do that for you. So in the factory default state, what does that mean? Well, in order to get into the factory default state, actually it's not factory default, it's actually the zeroized state. So to get in that state, you have to issue the command request system zeroize on a Juniper device. So we're talking about QFX devices at this moment. So I have to go onto the CLI and say request system zeroize, and that'll put it in the zeroize state. So what is the zeroize state? That is, the device will have no root password, and every revenue port will be in the default VLAN. Okay, in the default VLAN, there will be a single IRB configured, and that's what I'm trying to show you down here. Here's a typical QFX that has a routing engine. It's got a packet forwarding engine. It's got a management port configured for DHCP to obtain its IP address from DHCP. There's an IRB interface. This is not exactly what it looks like, but this is a simplified version. So an IRB interface basically allows you, if you try to connect to the IRB interface, you're going to end up interacting with the RE. That's why I show it here. But the IRB interface will be getting its IP address from DHCP as well. Okay. So because the IRB is attached to this same associated is the layer 3 routing interface for this VLAN interface, out of all these interfaces, the revenue ports are attached to the same VLAN. These DHCP discover messages will go out every single interface. Another thing that's going on all of these interfaces, not the management interface, but all these revenue ports, they have LLDP enabled. And so they're attempting to discover neighbors on the remote ends of these interfaces. So you want to make sure you're cabled properly and only cabled to other IP fabric devices because you don't want any random neighbors discovered. So the device is attempting to send DHCP discover messages on every single port based on what you're seeing here. Every single port is sending out DHCP discover message, and hopefully it's the AIO server that will respond in the end. And we'll see that topology here in a second. And what the AIO server is going to respond with is the IP address, the default gateway, the DNS server to use, and also it's going to respond with a configuration file to use. And then this device will end up downloading this using TFTP, a configuration file. So that's how this thing's going to initially get auto-configured and provide the ability for the AIO server to get into it and configure it for the routing protocols. Is based on this initial configuration file that gets downloaded. And we'll show a diagram here in a second of how that's done. And then there's similar configuration on the management port as well, whether it's EM0 or ME0, it depends on the QFX type. Okay, so again, this is the zeroized state is what we're trying to show you here. So let's move on. Okay, so this is going to be the topology we're working with. So this is our example network. So we're going to have a command server that's running the command user interface. We're going to have an all-in-one server that's going to run OpenStack, Contrail networking, and also a DHCP container. Okay, and they're going to be attached to this management interface. So that's what these dotted lines are, the management subnet here. Okay, so what we need to make sure is that these IP fabric devices, which I have 2 leaf nodes and a spine node, those also need to be connected to this same management network, which they are, okay, in our case. Now, the recommendation is that these are management interfaces, which you can tell that these are not management interfaces, but in my topology, I'm using Gigi 000 on the QFX 5100s. I am using the management interface of the QFX 10K, because again, because they're all sending DHCP messages out every port, the AIO server can send a DHCP message, and the DHCP offer messages, and they'll be received appropriately regardless of the interface type here. Okay, so that's what we see here. In order to reach the internet, the only way to reach it is through some sort of external router, which I have here is this default gateway for the AIO and the command server, and that's the way to get to the internet. Because remember, these guys are in the factory default state. That's what this node is down here. They're in the factory default state, so there's really no way to get out to the internet like you would hope to through the IP fabric. So initially, in this initial setup, my way out to the internet is through this path, through this external router, which may or may not be necessary. It was necessary for me to install these 2 devices with the correct software, but probably does not need to be there during the ZTP process that we're about to go through. Okay, so one thing you should notice are, what do we have here? We have an IP fabric that's cabled appropriately. Notice it's a very simple IP fabric, just 3 nodes, and they're cabled appropriately. They're going to learn LLDP neighbors here and here, which is what we hope. There's no extraneous LLDP neighbors. Since it's cabled appropriately, there's no links between leaf nodes, because you wouldn't want to have that in an IP fabric. If you did, then they would discover each other's LLDP neighbors, and a routing protocol would be turned on those links, which is not what you want in an IP fabric. You want it to follow the IP fabric path. So you have to make sure the cabling is correct. So things you need to note here is, okay, so I've got these interfaces, they're cabled and they're in the factory default state. Things I don't know are my autonomous system number. I don't know the loopback address. I don't know the interface address. I don't know the subnet that's going to be used here. I don't know, and that's on all these devices. This is all going to be configured for you. Okay, and you're going to specify what addressing is allowed, and we're going to call them the fabric subnets, and these will be the subnets that you'll use on these links. And then you'll also specify a subnet to use for AIO to auto-generate the loopback, the /32 loopbacks for each of these devices as well. And that's really all I have to say here. Keep in mind, the AIO server is going to end up acting like a DHCP server. So you only want to have IP fabric devices, besides the command and AIO server, that are statically assigned. You don't want to have any extraneous devices attached to this management subnet that might get an IP address from the AIO server, because to discover these guys, these IP fabric nodes, it's going to look at its DHCP clients list, and it will break the whole thing if there is a DHCP client of some random host that's sitting off of the subnet. So make sure only your IP fabric devices are on this management subnet. But what do things to also notice? Okay, well, I also have the command and AIO server that are statically assigned. Notice their addressing. It's on the upper part of this subnet. That's another key. Make sure that they're numbered up in the higher address space. Notice my gateway, which is again a host that's off of this subnet that I just told you not to do. If you're going to do it, make sure it's not this is not a DHCP interface. It's statically assigned, and that this numbering that we're using is in the higher range of this subnet. So notice the 254 is the highest host number. I use 253 and 252 here. And it's going to be these devices that get the DHCP addressing that starts at the bottom, right, at .1, .2, .3, right? If you happened, I've had this happen, if I numbered the command or AIO server .1 or .2, the AIO server, just acting as a DHCP server, will first try to assign the .1 address to, say, this device, and then the device will figure out that that address won't work, and the AIO will have to reassign it an address, and that's a problem because now it's got that .1 client is in its clients list, and it's broken. Things are broken. So don't have any random hosts that have DHCP enabled on their interfaces like these three devices here, and make sure if you do have other hosts on this subnet that they're in the higher host number range. Okay, there's that. So in order to do the Greenfield onboarding, you must have this in place in 5.0.2. You have to have that Contrail command server, because it hosts that Contrail command user interface. So to do this, you're going to to launch this whole thing, it'll be from the command server, from this command Contrail command user interface. You have to have the all-in-one server, which has OpenStack Contrail networking and also a DHCP container. Okay. It has all IP fabric devices must be zeroized and have their management interface on the same LAN segment as the AIO server. We talked about that. What does zeroized mean? Most importantly, it means that all the interfaces are sending DHCP discover messages, and all interfaces are enabled for LLDP so they can discover their neighbors. Going back, if I go back a slide, the QFX10K is going to discover 2 LLDP neighbors. And based on that neighbor relationship, bidirectional neighbor relationship, the AIO will detect that, be able to log into these devices. It can do that because of that that initial config file that's going to be TFTP'd to these devices, and it's going to discover what the neighbors are of each device. Okay, so they need to be zeroized so they can discover their LLDP neighbors on the IP fabric links. Also, the Contrail command server, the AIO server, and the IP fabric devices should be on the ZTP LAN. You can also have that external router if you want it, but again, we talked about the IP addressing issues. Any other discovered device can break that discovery process. You don't want any random hosts showing up in the DHCP clients list, so you have to make sure only the appropriate IP fabric devices are trying to obtain their IP address from DHCP. And the IP fabric devices should only be cabled to each other in a class topology. I mentioned that a second ago. For instance, if I go back here, if there were physical links between these two leaf nodes, that would break the topology of an IP fabric, and it would also cause the AIO server to auto-configure these for a routing protocol between them, and we don't want that. Okay, so the only exception to this rule is that we've got the LAN segment used for ZTP. You're putting the management interfaces there. Other discovered LLDP neighbors might cause unwanted routing configuration as well. So yeah, which I talked about. So good. Okay, that's it. So let's talk about the ZTP process real quick. So here's what our topology is going to look like. We've got our IP fabric nodes with their interfaces on the ZTP subnet. We've got the command user interface. And then on the AIO, this is what's going to happen. We've got a special container called the config API1 container, and it's going to control the whole ZTP process. There's also a DHCP container that's sole purpose is to provide DHCP server functionality on this subnet here. Okay, there's also OpenStack running on the AIO server, and OpenStack installs automatically with TFTP enabled. And that's what we have here, the TFTP boot directory, that is where files are downloaded or uploaded from, is var lib docker volumes ironic pxe data. This is the TFT boot directory. So what's going to happen is when you launch the Greenfield Underlay, the first thing that happens, right, because initially when the AIO box is installed, the DHCP container is not running. Okay, it's actually restarting over and over and over again until it can find a good dhcp.conf file, which it initially doesn't have until you start the Greenfield wizard. So once you start the Greenfield wizard, you're going to have to specify a few things. If I go back, you're going to have to specify the fabric subnets and also the loopback subnets that it can configure here. Okay, and you're also going to have to specify, what is the range, what is the management subnet as well, where we're going to run DHCP. You're going to have to give it that information in the wizard. Okay, so you give it that information and you say, okay, discover. What it's going to do first is it's going to push number one. It's going to modify the dhcp.conf file with the addressing for the management subnet. Okay, so that the DHCP container will now start acting as a DHCP server and dishing off addresses for this 172.25.12 network. Okay, and then the DHCP server is then started. Good, and then TFTP is already started. You just need to push this file. So what it's going to do, it's going to push this file called Greenfield Juniper.sh that gets merged into the existing config on these devices eventually once they're TFTP'd, and allows for the AIO server to actually log into these boxes once it's downloaded. So again, the config API 1 creates the DHCP conf file for this subnet and pushes that information into the DHCP.conf file, which causes the DHCP server to start up. And then number 3 is the Greenfield Juniper.sh script gets pushed down into this TFTP boot directory. Okay, so that's the start. That's what goes on the AIO. Now, all of a sudden, this device is acting as a DHCP server. Well, we know that these devices up here are sending DHCP discover messages over and over and over again. They've been waiting for somebody to respond. Now it can finally respond. So here's what happens. We see the DHCP request. Now this is one of our QFXs. We have our AIO server, and here's the exchange. So I brought down this 10K down here, for instance, and you see that it sends a DHCP. This is actually not a request, but a discover message that gets sent to this out on this subnet. Because the DHCP server has the file enabled and the DHCP container is up and running, it will respond with the IP address for that device in this subnet, probably in the .1, .2, .3 range, right? It'll be one of those hosts. If it's 3 hosts, hopefully 1, 2, and 3 get assigned. It'll assign the gateway. Now the gateway, when you specify it in the wizard, you're supposed to specify the AIO server, not that external router that we talked about. So that's important too. And then it'll also respond with the config file. It'll say, okay, you need to download this Greenfield Juniper.sh file. That's what it needs. That's what it tells this device. Then because it was told to grab this file, it will TFTP from this .253, the TFTP server. It'll download that script, which essentially is a Juniper config that needs to be merged, and it merges it into its config, and now it allows for the AIO server to actually log into that box. So what are the things that gets merged into what's in this Greenfield Juniper.sh script? There's the root password, the SSH is enabled, netconf is enabled, and LLDP is enabled as well, but it turns out it's already enabled. Okay, let's see. Oh, so before we go summary, we'll go ahead and start the process. Okay, so I'm stepping back, and this is our topology. We've got zeroized devices. We've got the AIO server and command server on the same subnet as these management ports. Okay, so I'm now going to go to the command server and log in. Okay, and I'll wait for that to happen. Okay, so we've logged into Contrail command, and in here we go to infrastructure fabrics. Now, what we'll see is there's no fabric, so we need to create one. So we'll hit create. And this is for Greenfield, we do new fabric. If it was an existing fabric that was already configured with an underlay routing protocol, we would click this. But this is a new fabric, and we're going to provision it with ZTP, okay? and it will auto configure all that stuff we talked about. So I'll hit provision. Now, we got to give our fabric a name. I'm going to call it Greenfield. Now, what do you want the root password to be on your devices that are being ZTP'd? So I'll enter that. It will get auto configured. How many devices do you want ZTP'd? In this case, it's 3 devices. Okay, so make sure that's correct. What's the overlay ASN? Now, you should know that Contrail networking uses 64512 by default, so we're just going to leave it for that. That's for the IBGP for EVPN. So there's this overlay that automatically gets configured, but we don't really worry about that too much in the Greenfield. Okay, so what are your management subnets? We mentioned this before, right? Our management subnet is the 172.25.12.0. Our gateway needs to be our AIO server, okay? Our autonomous system numbers, remember, we're going to have the autonomous system number be auto-configured for that underlay network. So we specify a few of them. Every device will have its own AS number. Now I only need 3, right? But I'll just keep it at 5. It doesn't matter, and it'll use what it can. But so this is the range. But every IP fabric device will be in its own autonomous system. Again, we're doing the eBGP type of IP fabric. Then our fabric subnets, we'll have, this is right off of that diagram I showed you. This will be you can go back and look at that diagram if you need to. And this will be our loopback subnets, okay? So these will be the ranges. So now, here's where I click next. When I click next, this is where the greenfield.juniper.sh files push to the ZTP directory, the TFTP directory, and also the DHCP configuration is enabled. And the AIO server will become a DHCP server at this moment, as soon as I hit next. So I'm going to go to next. Okay. Now the device discovery will start. Okay. Now you'll see here it talks about how it generates the TFTP file. It generates the DHCP file. It starts DHCP services. And then it will start discovering the devices based on what it finds in the DHCP client list. So you can get details here in the logs. Another place to find details, I always recommend this, is go on the AIO server and do a tail -f var log contrail fabric ansible playbooks.logs, and you can watch. This actually gives you the detailed information, while the here in this box, this log gives you kind of a highlight of what's going on. But these are all the details here going on in the background. So feel free to look there. If any problems happen, usually you're going to find the problems in here by doing that tail -f or going back and looking at that file later. So you'll see this device discovery progress bar. This bar will eventually build, and and hopefully become green, and the next button will become ungrayed. This whole process is going to take some time. It needs to discover lots of stuff. It has to discover all the interfaces, which there can be quite a few. Like on a QFX 5100, there can be like 70 interfaces. We're talking physical and logical interfaces. So it actually takes quite a while. It may take up to, I don't know, 10-15 minutes to get through this discovery process. What we hope, now that we're still back in the initial settings of DHCP and TFTP, so we haven't even actually found our devices yet. If I go over to the QFX 10K, for instance, so I'm going to go in there now. Okay, CLI. And if I say show LLDP neighbor, it's got neighbors, which is what we expect. If I say show configuration, we'll see. Okay, so it's still, see, so here's the log console. We're in the console, and we see that it's now downloading the script. It's executing the script. It's stopped now. The DHCP is turned off. Okay, of that interface. If I go in and if I say show pipe compare, I can see what changed. Roll back 1. So here it's turned off the auto image upgrade. Good enough. Let's go to, let's see what's going on over here. This should still be running. It's going to go on for a while. It discovered 3 devices. If I go up, let's look at the logs. So it discovered 3 devices. So it went into clients list and it found this in the DHCP clients list, number 1, 2, and 3. So these must be the QFX, supported devices. If they're not, this whole thing breaks. Okay, so here's 2, what it is. It's QFX 10K. Here's number 1, and it's QFX 5100, and there's also another QFX 5100. Notice that their addresses were kind of randomly assigned. Okay, and then now it's assigning the roles. QFX 5100s get this lean role. And the 10K gets the Juniper 10K role, which basically it tells it what type of configs get pushed. VXLAN config for QFX 10K is slightly different than a QFX 5100, and it's slightly different than a 5110, for instance. So that's what this is. Again, we're very early in the process. We're hoping to discover interfaces here. This will eventually get up into really high numbers in Greenfield, and it takes a while. So I'm going to pause this video and come back to it. Okay, while we're waiting for all the discovery to go down, I want to go back to, let's go to the AIO server, and let's go to the TFTP directory. I want to show you this. See this Greenfield Juniper.sh? That's the script that was TFTP'd by each device. So let's look at what's in that. I'll go cat on that. Okay, it finds the serial number. The serial number ends up being the host name of the device. I don't know if you remember that when I went to the 10K. Here's the serial number for the 10K. So all the host names, by default, in ZeroWise, there is no host name configured. So now it configures it with the serial number of the device. So that's what that first part does, is finds the serial number. It uses it as the host name. Notice then now we get a config being built, right? Used with this cat eof temp juniper.conf. We see that we're having a host name configured, a root password, the root password you entered. So this is the the hashed version of the password I entered, and also SSH and netconf is enabled, and also LLDP is enabled on every interface. Okay, and then it's load merged in. Okay, so that's what happens in the Greenfield sh Greenfield .juniper sh in this script here. Okay, so there's that. So that was TFTP'd by each of the devices, and they have that merged into their config. Again, we are waiting for the tail minus F to stop, and or waiting for this line to peak green and the next to show up. But we've got a lot longer to wait because these interfaces need to be discovered. So I'll come back. Here we see that the QFX, this QFX 10K, it's been 37 physical interfaces and 38 logical interfaces have been discovered. Now those interfaces right now are being imported, or they will eventually be imported, and that takes some time, and it has to do that for each of these devices. So again, this can take quite a long time to see that these interfaces get populated here. Okay, so now the discovery has finished. Notice all the interfaces that have been discovered. That's been onboarded. These devices, notice they've been given host names. They match the host names that we see on the CLI. I showed you the 10K earlier. This was its serial number, so they have their serial numbers or their host names. So you need to know their serial numbers, okay? And then so now what we want to do is go next, okay? Now here is where we assign roles. Now it turns out in the Greenfield, the roles aren't quite as important, because the roles really have to do with the overlay, okay? But it turns out you're not going to use this overlay functionality in Greenfield, but you still have to specify it. So look at my Brownfield Learning Byte to learn about these roles. I'm just going to go ahead and assign these, okay? But I won't talk about them because they don't really matter too much. This is obviously the 10K is a spine node, and we're going to give it the route reflector, DC gateway, and CRB gateway role. But again, That's not something to be concerned about so much. But the spine nodes, you want to give them those roles. At least route reflector and DC and CRB gateway. Okay, so DC gateway was one that was not really necessary. Okay, and then the leaf nodes, you're going to specify a leaf node, and there's only one option, which is CRB access, as well as the physical role also is going to be a leaf for the QFX 5100, which will be CRB access as well. Again, you're specifying the roles in the overlay VX EVP and VXLAN overlay, which you're actually not going to use in Greenfield. The expectation, okay, what's going to happen when I click, well, let's go ahead and hit auto configure, okay, and it'll start auto configuring. What it's going to do is configure the underlay first, okay, and let's just go ahead and look. Let's look at this slide one time here, okay? So what we're going to see, there's going to be resulting underlay topology. So based on the LLDP that was running here, they're going to the AIO is going to learn that these devices are neighbors in this fashion, where it's going to assign IP addresses to the interfaces that it learned LLDP neighbors on, which is here and here. Out of that address space that you listed in the wizard, it's going to assign loopbacks addresses out of that loopback subnet that you configured in the wizard. Okay, it's going to auto configure those for IP addressing. It's going to auto configure their host names, which I'm not showing the serial number version of the host names, but that's their host names. And it's going to auto configure their autonomous system number for the underlay, which is eBGP. So what's going to happen is the next step is it's going to configure eBGP sessions using physical interface addressing between all directly attached neighbors. So there'll be an eBGP session here and an eBGP session here. Okay, and then policy will be written to redistribute the loopbacks into this eBGP mesh. Okay, so I should be able to ping loopbacks from every device. Okay, now there will be a resulting overlay configuration as well, but you end up, and I'll show that to you in a second. So there will be an EVP and VXLAN, but it can't be used, and the reason why is because notice that there's no interfaces here for, say, for instance, your AIO, right? That's off of a management interface, right? We need the Contrail we need fabric facing interfaces on Contrail. So what the expectation is this, that then once you have this up and running, right? It's basically the Greenfield is it auto configures the underlay for you. Even though it does some overlay stuff later, this is what it's doing for you. This is auto configure. Now on 3 nodes, no big deal. If you had 50 nodes though, how much time would that save you? It would save you tons of time. In the hands-on configuration wise, it could really just in minutes auto configure these 50 devices for you. So that's kind of what you're looking for, getting out of the Greenfield. But what it does not take into consideration is this. What if I want, I normally don't want to have an all-in-one Contrail networking OpenStack device to do everything, right? I want to have, for instance, an OpenStack node, a Contrail control node, maybe redundant control nodes. I may want to have multiple compute nodes hanging off of different Tor devices, these QFX 5100s. I'm also going to need a CSN to provide DHCP and DNS servers to bare metal servers. So I'm going to need these devices to hang off of these revenue ports of the 5100. So and you're going to need to install Contrail and OpenStack here, and you want to be able to do that through the IP fabric. Maybe there's an internet connection here. So the idea is once you have your underlay configured with the AIO server, you can basically just pull the AIO server off the network, attach some bare metal servers to your top of rack switches, and then you'll have to manually go in and configure these interfaces to support the networking between these devices, and also be able to install Contrail on these devices. And then once you do that, you would do a brownfield discovery of the fabric so that you can do the bare metal server magic and the overlay stuff that you're hoping to do. So again, even though the AIO is going to configure this, which is next, it does do, oh sorry, I'll take that back. Give me a second, I'm going to modify this. Okay, so sorry I had a bad diagram before, but here, notice, remember I've got the command and AIO server. It will auto-configure this overlay of EVPN sessions with the QFX acting as a route reflector and a CRB gateway node, and these devices acting as CRB access nodes. And we see the multi-protocol EVPN BGP sessions that are established, but those, because you're going to just take away the command in AIO after you've built out the underlay, this will all get overwritten by the brownfield underlay onboarding that you'll have to do when you want to bring on your actual Contrail fabric, Contrail cluster, which will look something more like this. Okay, that you're going to want to install through the Contrail fabric and have it interact with the Contrail, with the IP fabric devices. So it's that. So let me go back. So I clicked next to get to auto configure. So now it's generating the underlay config and pushing it to the device. It's generating the overlay config, the temporary overlay config that gets pushed to the devices, and it'll establish all those BGP sessions that we're hoping for and the routing, underlay routing. Now, one of the problems here in 5.0.2 is that, okay, we've got a green line, it says finish, and in fact, we can click finish, and I will, and it shows my fabric here, no problem, okay? Everything that I would expect it to show here. But if you look in the background, because I'm doing that tail minus F command, there's still stuff going on. So really, it shouldn't allow me. I would expect that that would get fixed later on in future revisions. That I do have Ansible playbooks that are still running. They're still out there. It's not finished. It's really not truly finished. So I want to wait for those commands to finish, or these Ansible playbooks to finish before I move on. That's what it looks like in the end. At this point, once these Ansible scripts are finished, the playbooks have finished, we'll go in and quickly look at the results. So I'll come back after that time expires. Okay, so the scripts have now finished. So now we can go to, for instance, let's look at the QFX 10K, okay, which we see that it's got a host name now. Show configuration. And notice that the configurations show up in the form of groups. Okay, so these groups, so all the Contrail stuff comes in the form of groups. So if I say, oh, I pushed this too long, so hang on a second, we'll get this to stop. Okay, so we see here that lots of stuff has been configured here. Let's see. I've got SNMP has been configured. I've got my routing options have been configured. The autonomous system for the overlay has been configured. I've got, so this is the overlay. So there's overlay config. What happens is when you later on you'll do the brownfield onboarding to your real Contrail cluster. This will all get overwritten. Anything related to the overlay will get overwritten. So this group actually has no meaning, although this is the EVPN VXLAN sessions that I mentioned. So again, more overlay stuff that will get overwritten by the brownfield. But what you care about in Greenfield is the underlay, which won't get overwritten when you do the brownfield. So here we have those interfaces that were auto-configured with /30 addresses from that address space. The loopback was auto-configured. The router ID, load balancing has been enabled. You've BGP, so our eBGP sessions from interface to interface has been physical interface to physical interface has been configured. Policies for redistributing routes has been established, and that's pretty much it. Okay, that's what we're hoping for. So, again, if we had a 50 router fabric, all of them would have been configured for eBGP sessions between each other, and I'd be able to ping loopback to loopback. If I say, if I go on, the loopbacks, if I say show route, my loopbacks are /32 routes in this 10.10 range here. So there's 10.10, 251. And 250 learned via BGP. So these are the loopbacks of the remote devices. So I'm hoping I should be able to ping them because the underlay has been configured for me. And sure enough, I can ping the loopbacks of the downstream devices, okay, which is what I'm hoping for. And that is Greenfield Underlay. I hope that was useful to you. Let's go back. In this Learning Byte, we learned how to onboard and auto-configure the underlay routing for a Greenfield IP fabric. We know that the idea is that we would remove the Contrail command and AIO server. It's done its job at that point, and we want to now go back in, configure the external routing on our IP fabric to get to the internet and redistribute our directly connected routes into the IP fabric and install a Contrail cluster off of those top of rack switches so that we end up with something like this. Okay, but and then we'd have to onboard that IP fabric as a brownfield IP fabric. So that's it. I hope you enjoyed it, and look for some more of my Learning Bytes.
Visit the Juniper Education Services website to learn more about courses. View our full range of classroom, online, and e-learning courses. Learning paths, industry segment and technology-specific training paths. Juniper Network's certification program, the ultimate demonstration of your competence. And the training community, from forums to social media. Join the discussion.